Fortunately, many sprinkler systems are never needed. But when a fire does occur, the sprinkler system must operate perfectly, where the result would be loss of life or property. In this module, we'll be reviewing the purpose of sprinkler monitoring, the most common types of sprinkler systems, the types of monitoring equipment required in wet pipe systems, and the types of monitoring equipment required in dry pipe systems. When properly installed and maintained, fire sprinkler systems are the most effective way of saving lives and minimizing property damage. While a sprinkler system may actually extinguish a fire, its primary purpose is to keep the fire from spreading until the fire department arrives. However, most sprinkler systems are designed so that once the sprinkler is activated, water continues to flow until the system is shut down. Water flowing for hours through an open sprinkler head or broken pipe can cause major property damage. The purpose of sprinkler monitoring is to watch the sprinkler system for critical changes and then notify the proper authorities. Potter sprinkler monitoring products monitor water flow, system pressure, valve position, building temperature, and corrosion activity. Changes in any one of these elements may mean that the sprinkler has been activated and water is flowing through the system, or that there's a problem in the system that could make it inoperable in the event of a fire. In any of these instances, the authorities and building owners are notified so the situation can be corrected. Knowing what type of sprinkler system you're working with is the first step in assessing what monitoring equipment you and your customer will need. The most common types of sprinkler systems are wet pipe systems and dry pipe systems. As the name suggests, in a wet pipe system, water always remains in the pipes, and the system is connected directly to a water supply. Wet pipe sprinkler systems are the most common and dependable systems used in heated buildings and are monitored in one of three ways: using a Potter VSR vane-type water flow switch, using a Potter PS Series pressure-type flow switch along with a retard chamber, or using a Potter WFSR-F pressure-type flow switch with retard. The type of wet pipe sprinkler monitoring product that is installed may be mandated by local code, or it could be a matter of choice. In a straight pipe riser monitoring configuration, the main riser is fed directly from the water supply and then branches out to cover the entire building. These types of systems require a Potter VSR vane or paddle type water flow switch with a time delay or retard to prevent a false alarm. When a sprinkler head opens, the water begins to flow against the paddle of the flow switch. After the retard time expires, the contacts within the water flow switch trigger the alarm. All Potter retards are adjustable from 0 to 90 seconds to allow for natural fluctuations in water pressure without triggering a false alarm. Straight pipe risers don't have an alarm valve, but they do have a main control valve and either a riser check valve or backflow preventer. All control valves should also be installed with a supervisory or tamper switch. Depending on local or national codes, more than one control valve or water flow switch may be required to create zones for monitoring each floor of a multi-story building. These devices allow sections or zones of the system to be shut down for maintenance while the rest of the system remains functional. Having a water flow switch in each zone also enables firefighters to quickly locate the open sprinklers. Another way of monitoring a wet pipe system is with the Potter PS Series pressure-type flow switch, used with an alarm check valve and a retard chamber. The pressure-type flow switch is connected to the alarm port of the alarm check valve. The alarm port is open only when water is entering the sprinkler system. Some of this water is diverted through piping called trim to activate the pressure-type water flow switch or ring a mechanical bell called a water motor gong. Under normal conditions, the alarm valve traps pressurized water above the clapper and prevents reverse flow from the sprinkler piping. An external or internal bypass reduces the possibility of false alarms under low flow conditions. When the water supply pressure exceeds the sprinkler system water pressure due to a sprinkler opening or a surge in the supply water pressure, the valve opens and the alarm port is exposed to incoming water. When a pressure-type flow switch is used, it is normally installed off the alarm trim, on top of the retard chamber, and in line with the water motor gong when it is being used. A Potter bell would be wired to the PS series pressure switch to provide a local alarm if approved by the authority having jurisdiction, or AHJ. Retard chambers are metal containers that fill with water when there's a surge in pressure. They accumulate the water that flows through the trim so that a false alarm does not occur. Retard chambers require regular maintenance to make sure the drain doesn't get clogged with rust or corrosion. If a surge does not drain from the chamber before another surge occurs, the chamber may fill erroneously, causing the pressure switch to send a false alarm. This problem can be eliminated by using a WFSR-F pressure switch with a built-in retard. In this configuration, the retard chamber is only being used to delay the water motor gong. If there's no water motor gong, the retard chamber can also be eliminated. However, an automatic drain is still required with this type of monitoring in order to relieve the pressure on the line. Pressure-type flow switches must be installed in the line before any shutoff valve, or the shutoff valve must be monitored by a supervisory switch. Dry pipe sprinkler systems are usually installed in unheated buildings or where there's the possibility of sprinkler pipes freezing. While the pipes in this type of system remain dry when the system is not active, the dry pipe valve and other equipment the system is connected to do retain water and must be housed in a heated location or enclosure. This heated location should be monitored by a Potter RTS, room temperature switch, to notify of a potential low temperature condition. The way a dry pipe system works is by having pressurized air in the sprinkler pipes. The air pressure in the system keeps the dry pipe valve closed, preventing water from entering the system. This pressure should be monitored with a Potter PS series supervisory switch. If the air compressor fails or the system is leaking air, the building manager should be notified so the problem can be addressed before the system inadvertently operates. The Potter BVL is a quarter-turn bleeder valve that facilitates initial setting and ongoing testing of the Potter PS series pressure switch. This valve is a time saver and eliminates the need to shut off the water supply and air compressor, open a union, and bleed off air from the entire system. By using the BVL, only the air between the BVL and the pressure switch is bled. To aid in testing the low pressure switch, Potter offers a pre-assembled PS40-2, a BVL, and a high-quality pressure gauge in the model PS40-TM. Dry pipe valves have an alarm port that may run to the outside of a building to operate a water motor gong. Under normal conditions, this section of piping has no pressure or water. This is where a Potter PS series pressure-type water flow switch is installed to monitor the system. If a sprinkler opens, the air pressure in the system drops. When the pressure drops low enough, the valve will open, allowing the water to fill the pipes and flow through the open sprinkler. When the valve opens, it also exposes the alarm line to the incoming water supply and triggers the alarm. Dry systems must use a Potter PS series pressure-type flow switch. Vane-type water flow switches are not allowed on dry pipe sprinkler systems. When a dry pipe valve opens, the water rushes in with such force that the vane-type water flow switch could be damaged. There's no need for a retard or a retard chamber on dry pipe systems. In fact, retards are not allowed. If there's a shutoff valve between the dry pipe valve and the pressure switch, the valve must be supervised with the Potter RBVS. The Potter RBVS is a tamper switch used for monitoring the open position of a ball valve. This concludes Module 1 of the Potter Sprinkler Monitoring Product Training Program. In this module, we reviewed the purpose of sprinkler monitoring, the most common sprinkler systems, wet pipe sprinkler monitoring equipment, and dry pipe sprinkler monitoring equipment. If you have questions about these objectives, please review this module or contact your supervisor or Potter representative at 800-325-3936.